I'm super happy to have Kai with me. He will talk about how we can bridge HANA and Python with the SQL Alchemy dialect. So Kai, stage is yours, enjoy it.
Thank you very much. So, yeah, welcome everybody. My name is Kai Harder. I'm a developer within SAP, and I'm part of the SAP HANA infrastructure, basically rebuilding application services, tools for the SAP HANA developers, so the guys who actually develop SAP HANA. Today I want to talk about SQL Alchemy and how we can bring SQL, SAP HANA and Python together. I'm also a passionate Python developer. We also use a lot of SAP HANA and also SAP HANA Cloud in our day-to-day work. First of all, who knows SQL Alchemy? Just hands up. Okay, a few. Have you ever used SQL Alchemy-hana? Okay, that's good, but we have a mixed group. I like that. So I prepared everything. Okay. Yeah, so today's session is about, you guessed it, SQL Alchemy-hana. It's an open source dialect. It's an open source project. I am one of the maintainers. I do that together with my coworkers. And I would like to show you how this dialect works internally, how we use it, what it's meant to be a developer of such a dialect. Yeah, first, agenda. First, I introduce shortly SQL Alchemy. That was the good point, that not everybody raised the hand, so this slide is not not missed. Then I will tell you a little bit how SQL Alchemy-hana works internally. Then how SQL Alchemy-hana supports SAP HANA specifics, quirks, whatsoever. Then a little bit about schema migrations with Alembic. Also a short question, uses someone Alembic? Okay. Whoa, one hand, okay. And last but not least, some new features we recently brought to SQL Alchemy-hana, async and vectors. So this also crosses the bridge to another session where the vectors of SAP HANA was introduced. So first, introduction to SQL Alchemy. Let's just imagine you are a developer who wants to write a new application, and quite fast you realize, I need a data storage, I want to have a database. And by the way, you develop also in Python. In case you don't know Python, just imagine it. So now, what do? You maybe just start writing all the SQL plain in line. So select, star, from, whatsoever. And quite soon you realize, okay, that is not very nice. It looks ugly, all having the strings laying around. And also, if you want to rename something, it's quite a hassle. You want something more fancier. And this is the point where you maybe realize SQL Alchemy is the way to go. SQL Alchemy is the go-to project for database access for SQL generation within Python. And there are basically 3 features or use cases where you use SQL Alchemy. There are countless more, but let's just use these 3 as an example. First, I already said that you don't want to write plain SQL inside of your application. The next one is you don't want to deal with accessing rows and columns by indexes or by string indices. You want to use classes, right? You want to use class instances and attributes. You want to get syntax highlighting and features in your IDE of choice, whatsoever. And then also the last point, you maybe want to connect to different databases. So for example, we use SQLite when we want to test something locally. And for our production scenario, of course, we use SAP HANA. But we don't want to write the same SQL twice for 2 different databases because they have a slightly different SQL in the end. And that's a point where you use SQL Alchemy, where you realize, hey, that is the way to go. In the end, you need to have dialects. Dialects are like drivers in your PC. They translate between SQL Alchemy and the database below of it, and SQL Alchemy-hana is such said dialect. how does SQL Alchemy look like if you use it? Now you have an ORM example, or object relational mapper, in case you don't know the term. And let's just ignore some specifics like this magic base thingy. Just ignore it. I just added it for completeness so that the example is not completely wrong. And you directly see the simplicity you get with SQL Alchemy. You have like your class, it's speaking, okay, it's employee. Guess it's an employee. There's nothing to be ambiguous about. You directly specify the table name. You have 3 columns. You can directly specify the types. What is the primary key? How long is the name of such employee, etc. Then there is also this magic session thingy. Just think of it like kind of a transaction. It's not completely right, but let's keep it simple for now. We just generate a new employee instance. We just add it to the session so that the transaction is aware of the existence of that object. Then we commit it. And behind the scenes, an insert statement is executed. We don't see it. We don't care. We just know it's there. I committed it, and that's it. Of course, we want to get data back. And with the below statement, we can directly select all employees which work in the engineering department. And you directly see you have all these attributes, and you don't deal with all these SQL details, but you just write what you want in Python with Python functions, and you get not arrays back or whatsoever, but you get class instances back. And that's the important point of SQL Alchemy. So, talking enough about SQL Alchemy, let's talk about SQL Alchemy-hana. And first, how do you use SQL Alchemy-hana? You need to install it. Obviously, you can use the package manager of your choice, pip, UV, or whatsoever you want to use, poetry maybe. You just install it, and then it's there. Obviously, you should also install SQL Alchemy. Then you need to connect to your database. Now is the point where you should also ask yourself, do I have already an SAP HANA? If you don't have one, you maybe should buy one. You do that by using a so-called engine. You just have then your URL. It's like a standard URL you could type in your browser with user, password, host, and the port. And then there is this magic HANA in front of it, HANA : // With this magic string, SQL Alchemy knows which driver, which dialect to load. So it knows now, okay, I need to look up which dialect supports HANA. SQL Alchemy-hana says, here I am, please select me, and SQL Alchemy, let's go. Here's all the stuff I need to have. SQL Alchemy-hana does the job. SQL Alchemy is happy. SQL Alchemy-hana is happy. You are happy. We also support tenant DBs and also the HANA user store key in case you want to use it. And maybe it's also now a good point in time to say we use SQL Alchemy-hana for critical operations within SAP within my department. So it's not like a side project laying around on GitHub and getting maybe a commit every few then, but it's really critical business software for us. A dialect contains of several compiler classes. You can think of it like a plug-and-play system, or you could just extend the parts which you need to extend. Everything else you just leave to SQL Alchemy. Because SQL Alchemy supports most of the things, it highly depends on your database how much you need to adapt, to change, to extend. The exact details of all these things can be very complicated. The whole dialect has about 1,400 lines, something like that. But basically, you deal with DML statements, with type name rendering, because there are types which are not supported by all SQL, by all databases. You need to deal with DDL statements, with quoting identifiers. I will talk about that in a second, very interesting topic. And also, last but not least, with sequences, because HANA has no auto-increment feature, but you deal with sequences. And SQL Alchemy normally knows it somehow, but does not know how HANA sequences work, so we need to tell it. Now, maybe one of the most interesting things where HANA is different to other databases or to the SQL Alchemy standard, that is not like the real SQL standard, but it's like the most common set the maintainers of SQL Alchemy came up with. And obviously, they don't know HANA, so we need to support to adapt several things. First, let's talk shortly about SQL generation. As I said, every database management system has its own way to write, to have SQL, and SAP HANA is definitely no exception there. One of these things is every select must have a from clause. In SQLite, you can just say select one. Nothing else. That's it, you get a one back. In HANA, you need to write SQL select one from dummy because it's not otherwise supported. So we need to tell sqlalchemy, hey, in case the user did not specify a from clause, you need to add this default from dummy. Also with offsets. Offsets are not supported standalone, they're only supported with an additional limit, meaning you cannot just say select blah, 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 offset 10, but you need to say limit 10,000 something, offset 10. And what we then do if the user did not specify a limit by its own, we just add a very, very large number. It's like the integer maximum, the maximum size of a result set, so that you get all the data back you expect. But it's not a thing we just need to care about. Also in the operators, there are differences. Unfortunately, its distinct form is not supported by HANA, meaning we need to build this very interesting statement. Took some time to figure out how to write it completely, but just to show you, hey, there are stuff which is not supported, but with dialects in sqlalchemy, you can find ways to work around that. So you can even, so the user does not care. The user just says, hey, is this string form? And we, within sqlalchemy-hana, we just take care of that. Even though this is maybe not the most performant statement, and that is maybe in high performant application then of relevance, but for an ordinary user, the ordinary user can just write it without worrying about the details. Identifiers. Identifiers are a very interesting thing. Because HANA, in difference to many other database management systems, supports case-sensitive identifiers and special characters. I think if you have ever seen ABAP tables, you know that they can be very funny names, and all of them are supported in HANA. However, within sqlalchemy, you normally use lowercase names for identifiers and use uppercase in SQL, and so we need to build a little bit of translation here and there. Types. Types are also very important topics, because in sqlalchemy you can just say, I want a column of type string. And what is now a string? So some databases support string natively. In HANA, they are called varchars, nvarchar, whatsoever. Also, datetime is called timestamp. These are trivial translations we can just do for the user, but there are also types like tinyint, alphanum, important for ABAP, and also small vector if you deal with vectors, surprisingly. And all of these then are supported by sqlalchemy-hana. We just provide the implementation so that you can just use it in your application without taking care of all the details. You can just say string, and we know, okay, that's an varchar. Let's just generate an varchar for the user. Next topic is also very interesting because schema migrations. Following issue, you have now your very cool application. You use now sqlalchemy. You also use sqlalchemy-hana. You think I'm a cool dude. I don't know. But next thing is somebody comes from you and to you and says, we need a new column because there's a requirement. We need to rename something. We need to migrate the data in some way. We need to transform the shape of it. And obviously, you can just like execute SQLs at the start of the application. You can maybe just go to your productive database and just execute it directly. I would not recommend that, by the way. But here's now the chance to use Alembic. Alembic is basically a kind of Gitty thing where you write your migrations as a kind of revision, as a kind of commit. And you can just say, tell Alembic, hey, please upgrade my database to the latest revision. And Alembic knows exactly which part of all your revisions to execute, to migrate. And of course, for DDL statements, they are even worse than DML statements because there are way more differences. within the different databases, and we also need to support these. So here just the example with the add column, because you need an alter table before, you need to have the brackets exactly at the right position, because without the brackets, the SQL is just not right, it does not compile. And this is also some code we needed to write in order to support Alembic, but with that, now we have the complete journey. Transactional DDL. Scenario. You have multiple DDL statements within your migration, and you want to execute it. You execute your first, maybe it's an alter table. Then you execute your next one, it's, I don't know, a drop. Then you execute the next one, and this one breaks. Now have fun, because now we have a broken database. Because every DDL statement is committed right away. So it's already live on your productive database. Now it's the time to call the DevOps and to explain that something messed up and that you have now at 3 a.m. a very cool time. That's now the point where transactional DDL comes into play. It's a very cool HANA feature. In my opinion, it's underestimated and also not well known. And what you basically can tell is, hey, please execute my DDL statements within a transaction. Meaning, if the last DDL statement fails and makes a rollback of the transaction, every DDL statement in front is also rolled back. Alembic supports that too, so there's a little flag you can set. sqlalchemy-hana supports it, and that's also important to note, HANA is one of the databases who support this feature. There are not that many databases outside in the wild which support it. So, last topic, async and vectors. Why do we care about async? Because there are many libraries like FastAPI and other async I/O apps who want to utilize it and who have this interesting event loop, so that if you're currently waiting for I/O, you can do other things and don't wait for boring stuff which you just waste time. It's a pretty new feature we brought into sqlalchemy-hana. In the end, it's also not that complicated, because instead of to say create engine, you just say create async engine. Instead of having a session, you have an async session. Instead of having a connection, you guessed it, you have an async connection. But in the end, it makes your application, in the best case, go faster if you have mostly I/O bound workload to do. The other thing is, as said, cycling back to the session which happened, I think, 2 slots ago about vectors in HANA, that we also supported. So you can create vector columns, and when you create your engine, you tell how should the output type look like. Do you want a list? Do you want a tuple? Or do you want a memory view? Because there is not like a vector type within Python natively. Of course, with NumPy and pandas there are some, but natively there are not. So you need to specify what you want to have. Which also brings me to the point, how do you use it actually? You need to use the real vector type for your column. You tell it, okay, it's a list of floats. I want to have, for reasons, 1,536, very nice number, of vectors in it. And also sqlalchemy-hana supports all the functionality by HANA, because you need a small wrap around it. So you can use cosine, similarity, L2 distance, and you name it. So sqlalchemy and sqlalchemy-hana are ready for the AI era, where you want to have these kind of functionality. Now comes the coolest page, resources, some important links. Here you see the documentation for sqlalchemy, for sqlalchemy-hana, and also for HTTP CLI. That is, by the way, the Python driver. So this, if you look at it from a layered perspective, it's sqlalchemy, then comes sqlalchemy-hana, then comes HTTP CLI, which does all the connection stuff, and then comes your SAP HANA database. And last thing I need to say is thank you very much for your attention. I'm right in time. Thank you very much.
Exceptional timing. Awesome.
Thank you very much. And last sentence, so if you want to connect with me, here's my email address. There's also my GitHub profile in case you want to see what I'm else doing on GitHub. And I will also be, after the session, in the expert corner.
Yes.
And in case you want to connect with me, have a chat about this session or about Python in general, I'm happy to have that. Thank you.
We unfortunately already overruled your slide with the Q&A slide, but
oh, okay, never mind.
So sorry for that. No, but I feel like people will definitely connect with you directly. Now, fun story. Actually, I remember when I was a developer, I was working with Python, and this transaction rollback feature is actually quite handy, but I remember the times where I was just brutally turning it off and screwing my database because of that. So this is really a big feature and actually a very beneficial thing, so thanks for pointing that out. Big fan of SQL Alchemy. Any questions here in the room as we are in the middle of Q&A? Yes, there we go. Okay, let's see. That's a big... Whoa, whoa. Almost. Yeah.
A great presentation. Quick question: are all HANA functions supported? Because I always have this with wrappers around HANA stuff that suddenly the geospatial functions are not supported. So is everything supported and is everything available? And is there a generic way to get to everything, especially that if it's new, or do you always have to specifically add that in?
I would say it depends. Maybe first small point, both HANA on-prem and HANA cloud are supported. That's maybe already important. For your functions in SQL Alchemy, there is like a generic wrapper, so you can just say, SQL Alchemy, please generate me a wrapper for whatever spatial function. It has this input, it has this output, and then SQL Alchemy is happy to serve that. In case it's getting a little bit more complicated, some translations, for example, like Python specifics are needed, you can request that for SQL Alchemy-hana. We are happy to add that because for such functionality, it makes then also sense, for example, for special typing whatsoever, to have a more common wrapper within SQL Alchemy-hana so that also other users can benefit from it and so that we don't have duplicated code flying around.
Thank you.
All right. There seems to be a follow-up. Yeah.
Thanks a lot for your presentation. You mentioned Alembic as a tool for schema evolution. And my question would be, how does it relate to the HANA deployment infrastructure, HDI, which also does schema evolution, and I think also does transactional schema evolution? So how do they relate, and when do you recommend using which?
Interesting question. So maybe a small disclaimer, I know HDI a bit, but I'm definitely no expert there. I know that they support something like that. I would say it depends on your use case. If you already are in the HDI area and if you already have all your schemas defined in HDI, then please use that feature. But for example, our application, for reasons, does not run on HDI. So we manage all of our schemas within SQL Alchemy. Our application has never seen HDI at all. In this case, it just makes no sense to just utilize this single feature of HDI because that would be a hell. So in this case, Alembic makes the most sense. So I would say it depends on which environment you already are into, and then just utilize whatever fits your needs.
Yeah, cool, thanks.
Awesome. Any further questions here in the room? That doesn't seem to be the case. Then let me say thank you once more to you.
Sure.
Before we then start with the next session shortly with our dear colleague Hai Bauten, who will talk about the reimagined certification process for SAP HANA. Thank you so much.
Thank you very much.